So this video is on Integrated 1, Unit 5D Day, which is Friday's homework, Unit 5 homework 14. So on this first section, these first three problems here, they want us to find the missing pieces, okay? Whether you have to write the sequence, you have to give the recursive, explicit, formula, list, whether it's arithmetic or geometric, okay? And find f of 10 for each of these. So when we're looking at this particular sequence, we need to decide what we're doing. And looking at this, I notice that this looks like we're adding 7. Yeah, here, we're adding 7 in each of these. So since we are adding 7, okay, that's what we're doing. That means that this is going to be arithmetic. Okay, arithmetic. And so let's answer the other questions they have here. So they want us to write the recursive formula. Okay, let me just make this a little smaller. So the recursive formula is going to be f of n equals f of n minus 1. That's how we're always going to start. And then what we are doing, we are adding 7. So we're going to put plus 7. Now, we also always need to have a start. We need to know where we're starting. So I am just going to grab this highlighter. And so this is my start, that -2. That's my first term. That's my f of 1. So I'm going to say f of 1 is equal to -2. So not only do I know that I'm adding 7 in the sequence, I know what to start with when I'm adding my 7. Now for my explicit equation, I'm going to write it in two different ways, okay? So if I want to start with this -2, I just need to remember that that is my 1. So -2 plus, and what I'm doing is I'm adding 7, n minus 1 times if this is my first term, okay? Now, if I'm not going to use my first term, let's say I'm going to use my 0 term. So let me just jot down here real quick. F of 1 is -2, and f of 0, if I'm going the other direction, okay, I was adding 7, so going backwards, I'm minusing 7. This would be a -9. So the one I'm writing in red is also an explicit equation. I'm starting with my 0, though, which is -9. I'm adding 7, and if I start with my 0, then this is just an n. And a little reminder, if it's arithmetic, the n is not in the exponent, only if that's geometric. Okay, and this is arithmetic because we are adding. And then when they want us to find f of 10, that means we're literally going to put 10 into the equation. So let me put it into the red one. Here, I'll use red. I'll put it into the red one. So if I'm going to work out f of 10, which means the 10th term, I'm going to go -9 plus 7 times 10. I get 70 plus a -9 is going to be 61. And that is my f of 10. Okay. Okay, on the next one, what we're doing is we have a word problem, a little situation. It says I have $3 and each week my money doubles. So that means we are timesing by 2. Okay, we are timesing by 2. Timesing by 2. So that means that this is going to be geometric. Okay, now we need to decide what this 3 is. Is this my 1 or is this my 0? So I have $3 and each week it doubles. It hasn't doubled yet. So this is not week 1. This is week 0. So f of 0 is 3. Okay, it's not 1. Once I double it and make it a 6, then that's going to be my first week. Okay, so first 5 terms of the sequence. Now, this 3 is my 0, but it's not my 1. My 1 is going to be multiplied by 2, so that's going to be 6. Okay, so it's going to be 6, and then I'm going to double that, 12, 24, 48, and 96. Okay, so when they say first 5 terms of the sequence, they're talking about first term, which is your 1, not your 0. Recursive. So the recursive formula for this, f of n is equal to f of n minus 1. And then what we're doing is we are timesing by 2. Now I also need my start. So I'm going to give the f of 0. Here, I'm going to squeeze it up here. My f of 0, which is 3. Okay, so saying that my f of 0 is 3, and then giving this, that's my recursive. My explicit, since I have my 0, I'm going to start with my 0. I'm going to do my 0. So it's going to be f of n is equal to 3. That's what we're starting with. That's our 0. I am timesing it by 2. When you times, your n is in the exponent. And it is going to be an n because this is my 0 term, not my first term. Then the next thing they ask is they ask us if this is arithmetic or geometric. And let me just get this a little more focused, sorry. And so this is geometric, okay, geometric. And then they want us to put a 10 in here. So I need to find f of 10, the 10th term. So that means I'm going to put 10 right here. So I'm going to zoom in a little bit. So I'm going to do f of 10 is equal to, I'm going to use this equation here, 3 times 2 to the power 10. I'm going to put that into my calculator. Okay, and what you don't want to do not do 3 times 2 and press equal. Okay, that would be 6, and then times, raise that to the power 10. That's not right. The 2 is the only thing being raised to the power 10. So I'm literally going to go 3 times 2 raised to the power 10. And on these graphing calculators, the raised to button is this one right here. Okay, and then I end up with 3072. So this is going to equal 3072. 3072. Okay. Next one, number 3. Okay, so on number 3, they're giving us the recursive one. Okay, so I'm going to do this. I'm going to highlight this. Okay, and I am going to draw an arrow here. This is my recursive. F of n is equal to f of n minus 1 plus 0.5. I'm adding 0.5, and my first term is 3. So here they want us to actually write the first 5 terms. So here my f of 1 is 3, so I'm going to start with 3. And then I'm adding 0.5, so it's going to be 3.5, 4, 4.5, 5. And again, the recursive formula I wrote here. Okay, I already have it. My explicit formula, f of n is equal to, and I'm going to write this in 2 forms. If I'm starting with my f of 1, 3, I am adding 0.5 n minus 1 times because I am starting with my first. Now, if I want to go backwards and find my 0 and start with my 0, so again, if this was my 1, going backwards, I would have subtracted 0.5 and I would have had 2.5. So I could have started with 2.5, which is my 0. I'm adding 0.5 times n. Then they're asking us if this is arithmetic and geometric. Since we're adding, it is arithmetic. And then the last question here, let me zoom in a little bit. They want us to find f of 10. I'm going to do it into this one right here in red. So here. So I'm going to find f of 10. 2.5 plus 0.5 times 10. Now 0.5 times 10 is going to be 5. So this is going to be 2.5 plus 5, which is 7.5. And that's f of 10. Okay. On number 4. Okay, and on number 4, again, we're doing the same ideas. On this one, I'm just going to kind of zoom in, okay? And I'm going to write the number so we see it. There's a point here, okay, at 10. Okay, so that's at 10. This point here is at a height of 5. So right now I've either subtracting 5 or dividing by 2, one or the other. When I get to my next one, I see I'm not subtracting 5 because I'm not down at 0. It looks to me like I am at 2.5. So that means I am dividing by 2, dividing by 2, divide by 2, and divide by 2 is the same as multiplying by the reciprocal, which is 1/2. So I am multiplying by 1/2. And I am just going to list these other ones here. So if I take half of, let's say 250, like a $2.50, I'm going to get $1.25. And then when I take half of 1.25, that's not going to be nice. I'm going to get 0.625. So this one here is at 0.625. So I think one of the first questions is going to be list the sequence. This is where you have to be careful. We're not going to start with this 10. 10 is not my first one. 5 is. Okay. So when they ask me to list the first 5 numbers in the sequence, I'm going to start with 5, 2.5, 1.25, 0.625, and I need to do one more. And that is 0.3125. I'm going to put a 0.3125. So again, this is my f of 1. So I start with this. Then recursive. So I'm going to start with my f of, I'm going to start with my f of 0. My f of 0 was 10. Okay. And then I have f of n is equal to f of n minus 1. And what I'm doing, yes, I'm dividing by 2, but you want to think about it as multiplying by 1/2 or 0.5. Okay, that's multiply. Then explicit. Okay, again, I'm going to start with my 0, which was 10. Well, first let me start with f of n. That would be nice. Okay, so f of n is equal to 10, and I am timesing it by 1/2. Anytime I have a fraction or a negative, I usually like to put in parentheses. And since this is my 0, this is going to be to the power n. Okay. If I had started with the number 5 here, which is my first term, then I would have had 5 times 1/2 to the n minus 1 because it's my first term. Okay, this is geometric. And then they want us to find f of 10. So f of 10, I'm going to take 10 times 1/2 to the power 10. And let's see what we get. So I'm going to try and clear all that. So 10 times 1/2 to the power 10. And I end up with 0.009765. So let's say about 0.009777, let's say. Okay, about. On these calculators, if I hit math, and number 1 there is fraction, it's also exactly equal to 5 over 5 over 512 is what it equals exactly. Okay, if you don't want to have it rounded. Okay, number 5. Okay, so on number 5, they're giving us the explicit equation. This is my explicit equation. So I'm going to put that for my explicit. Now here, when they want the first 5 terms of the sequence, this number 1, I can just put in 1 and 2 and 3 and get my answer. But since this is a 2 and this is an n, f of 0 is 2. And what I'm doing is I'm timesing by 3. Okay. Now, if they want us to list the first 5 terms, again, this is f of 0. My first one is going to be 3 times that, which is 6. Then 3 times that, 18. Then 3 times that, 54. And then 3 times that, 162. and 3 times that, 486. Those would be the first 5 terms of the sequence. Now, if you want, you can go 2 times 3 raised to the power 1, and you'll see I get that 6. And if I wanted the second term, I can put a 2 in here, and you see I get my 18, and so on. So you can also do it that way. Okay. So then my explicit and recursive. Okay, so the recursive, f of n is equal to f of n minus 1. And what I'm doing in this is I'm timesing by 3. And I'm going to write right above it, f of 0 is 2, so we know where to start. And then this one here, I'm going to highlight it. That is my explicit. So I am going to draw an arrow here, and that is my explicit, or you can rewrite it. And since I'm timesing, that means that this is geometric. And then the last thing on this particular problem is we're going to be putting in a 10 here. So I'm going to be doing f of 10 is equal to 2 times 3 to the power 10. And I'm going to put that in my calculator. 2 times 3 to the power 10. And I get, let's see, 118,098. Okay. On number 6, okay, and just a little quick note, on number 4, it was curved. It wasn't a straight line. Exponentials are geometric sequences. So this is a geometric sequence, where this one over here is linear. Arithmetic sequences are linear. So let me just kind of put the values we have here. So we have a 10, we have a 7, we have a 4, we have a 1. So it looks like I am subtracting 3. That's what it looks like I'm doing. And when they ask me to list the first 5 terms, I'm not going to list this 10. That's my 0. I'm going to start with my 1, this one right here. So I'm going to start with 7. So I am going to, and I'm going to do this in a different color since I have that number written there. So this is going to be 7, and then 4, and then 1. And then if I subtract 3 from that, -2. And if I subtract 3 from that, -5. Those are the first 5 terms. Then I'm going to do recursive. Whoops. Okay. So my recursive formula for this one, a little bigger. My recursive formula for this one is going to be f of n is equal to f of n minus 1. And what I'm doing in here is I am minusing 3. And I also need to write, and I will write it over here since I'm kind of scrunching this in, f of 0 is 10, or I can write f of 0 is 10, or I can write f of 1 is 7. Let me get this back. Okay, so let me erase this. I'm running too close to the edge there. So this is f of 0 is equal to 10. And I'm going to move this, see if I can move it real quick. Move it up a little bit. Okay. Now my explicit one, I kind of wrote this there for my explicit. I kind of wrote too big here. Let me kind of zoom in a little bit. Okay. And let me get rid of this. That was from before. So for this one, I'm going to do it in blue. Okay, this is my explicit that I'm going to write in blue. Get my blue, sorry. So it's going to be my explicit. And so down here, I'm going to write f of n is equal to, and I'm going to start with my 0, my 10. And I am not timesing it, sorry, I'm minusing it by 3. Last one was timesing. Minusing it by 3, and so it's a minus 3n. And this is going to be arithmetic. And then they need us to find f of 10. So to find f of 10, I'm going to go 10 minus 3 times 10. So this is 10 minus 30, which is negative 20. And that's your answer. Okay, on the next page, number 7, it says, on my birthday, I get my own personal cake. Each day I eat 14% of the cake. We're going to write an explicit equation. We're going to do a graph, recursive equation, and a table. Okay, so for my equation, explicit, I'm going to do f of n is equal to 1 for one whole cake. Okay, for one whole cake. And so we're starting with a whole cake, 1, and each day we eat 14%. So if we eat 14%, how much is left? Well, we're going to take 100 minus 14, which is 86. So this is going to be times by 0.86. And we're going to raise it to the power n. That's going to be our explicit equation. Okay, so for our recursive equation, I am going to have f of n is equal to f of n minus 1, and I am multiplying by 0.86. And we're starting with 1. With 1, but this is my 0, right? My whole cake. My f of 0 is one whole cake. Now for my graph, I'm going to do my graph in Desmos. Okay, so I have my Desmos here, and I'm going to do my equation. F of n is equal to 1 whole cake times 0.86 raised to the power n. And here's your graph. Okay. Now, if I want to get the values, get the points on a table, we can use this plus to get a table if I am going to write the table and put the values in it. I want the computer to get it from this equation. So I'm going to come over here to this little setting symbol, and I'm going to grab that. And now I want to put in some other values because it always goes from negative 2 to 2. So I'm going to go 3, 4, 5, 6, 7, 8. Okay, and I can keep going. Okay, and there's my picture. Now, just a little reminder, this curve helps us to model this and to predict, but the curve is not the sequence. The sequence is these points. Okay, so a sequence is always discrete. Okay, but this curve models it. Okay, I am going to come here to my wrench. I'm going to actually label my x-axis as number of days, and I will label my y-axis as amount of cake left. Okay, amount of cake left. So amount of cake left, number of days. And then I'm going to come up here to the share, and I'm going to export it. I'll add it onto our worksheet. Okay. Okay, there we go. And then we have our table. And I'm actually going to come here and steal the table too. So I'm going to come back to Desmos. Now, up here, I don't have an option for the table. This copy image, this link would copy the whole page, copy this whole thing, but I just want this table. So you're going to do a screenshot. Okay. I'm going to do a screenshot. You can do a screenshot. Okay. And so I'm taking that and I'm going to upload that onto our worksheet for our table. And here I'm going to, hold on a second, I'm going to move this. And then you can always enlarge it by clicking on the corners. Okay. So next one, this one here. Okay, so let's take a look at that problem. So on this one, they want you to want us to match the recursive function with the equivalent explicit function. Okay. So looking at these, you'll notice these ones are f of n minus 1. These are your recursive ones right here. Okay. So these ones here, I'm just going to write these ones. Here, I'm going to turn it so I can write better. This is our recursive ones. Okay, all of those are our recursive choices. And these ones that do not have the f of n, these are our explicit ones. And so we're trying to match which ones go with which. So a couple things to look at. This one's an add 6, this one's an add 12, this one's a times by 6, this one's a times by 12. So that can kind of help us here. So add 6. That's not an add 6. This is an add 6. You might think this is an add 6, but this is really adding 12 over and over and over again. This is starting with 6 and adding 12. And this is starting at 6 as our 0. Okay. So this one is starting with 12 as my 0. And then I'm adding 6 over and over and over again. And that's actually going to be this one here. So this is this. And you might say, well, what about this f of 1 is 18? Again, I am adding 12. Adding 6, starting at 12, going backwards. That's my 0. So if I was here at 18 and I went backwards and subtracted 6, I am going to get my 12. Okay. This one is an add 12. This is not add. This has a 12, but it's not add. This is adding 12. I'm adding 12 over and over and over again. So this is the one I want. Now this one here, we're timesing by 6. This one here, we're timesing by 12. So here, this is 6 to a power. This one here is 12 to a power. So this one is multiplying by 6, and this one is multiplying by 12. That's what they want. Now, at the bottom here, for each of the following, find the missing values and say what the constant difference ratio is. Okay, so for this one, they're saying that this is arithmetic. They have to tell us that. So different ways to do this. This is how I'm going to think about it. Okay, here I'm starting with my 5. Okay, then I'm going 5 plus d to get this one. This one here, it's 5 plus 2d. Then here, I'm just going to underline. Okay, so that's my 5. That's this one. This one, I'm going to add again. So that's going to be a 5 plus 3d. And then for my 25, that is really a 5 plus 4d. And then we can solve this. Okay, so I'm adding d once, twice, 3 times, 4 times to get to the 25. That's where this equation comes from. So I'm going to solve 25 is equal to 5 plus 4d. I'm going to subtract 5, I get 20. I divide by 4 and I get 5. So My constant difference or common difference is 5. And if they want me to fill in the missing terms, I am adding 5. So this is 10, 15, 20, and then 25. On number 10, this time it's geometric. So for this one, this is going to be 3 times r. This is 3 times r squared. This one's 3 times r cubed. And then this one here is 3 times r to the 4th. This is going to be my equation. 3r to the 4th equals 243. And I'm going to solve. To solve this, I divide both sides by 3. When I divide this by 3, I get 81. And then on my calculator, I can take the 4th root of 81. And to take the 4th root of 81, this button here, math, we hit math. Number 5 will take any root. Number 4 takes cube roots. Number 5 takes any roots. So I'm going to do 5, and I want the 4th root of 81. And when I do that, I get a 3. Now, when you're doing this and you are taking any even root, you always get a positive or a negative. So this is going to be a positive or a negative 3. So my common ratio or constant ratio is a positive and a negative 3. And that's because anytime you have pairs, a negative and a negative makes a positive. So even roots will have pairs. So you have to give me both. Now, what does that mean? That means that if I times by 3, positive 3, I would have gotten a 9. I would have gotten a 27. I would have gotten an 81. But when I times by the negative 3, this one would have been negative. So that means that it would have been positive for the first one, but negative for that second value. Now, a negative times a negative is a positive. So this one is not a minus. And then when I times by a negative again, this one was a positive originally, but now it could be negative. So you're going to have alternating signs. Okay, alternating signs. Or you can just do it once. Maybe it's easier just to do it once with the positive 3. So if I'm doing it by the positive 3, I have 3, 9, 27, 81, and our 243 that was given. But if I'm doing it by the negative 3, okay, I start with 3. I times that by negative, I get a negative 9. Times that by negative, I get a positive 27. I times that by negative, I get a negative 81. I times that by negative, I get a positive 243. And so you'll notice my 3 here, this was a positive and a negative. This was positive 27. This was positive and negative. And then this was positive. A little trickier, that last one. And that is the end. Hopefully this helps. If you have any questions, please email me over the weekend because we are testing next week. Not on Monday, but we are testing. It's coming up. So you want to make sure you guys understand how to do these. Have a nice weekend.